Welcome to Olympian Water Testing, giving you the best in water analysis. Today we're looking at the NIH, National Library of Medicine, at iron overload and immunity. Now we're taking a look at how iron affects the immune system. Is it good, bad, and how does it work with your immunity? Progression and the characterization of genes involved in the control of iron hematosis in humans and mice have improved the definition of iron overload and the cells affected by it. An iron overload is simply getting too much iron in your system, whether that is from water or your diet or a combination of both. And the cell involved in iron overload with the greatest effect on immunity is the macrophage. Intriguing evidence has emerged, however, in the last 12 years, indicating the pharyngeal iron overload is linked to genes classically associated with the immune system. And it offers an update of the genes and proteins relevant to the iron metabolism expressed in cells of the innate immune system and address the question of how this system is affected in clinical situations of iron overload. And the relationship between iron and the major cells of adaptive immunity, the T lymphocytes, will also be reviewed. So they have the two immunities here, and they've seen a growing understanding of numerous factors of the immune system beyond classical attributes of adaptive immunity, the antigen specific, and the memory. And the key effector cell of adaptive immunity is the lymphocyte, a cell no longer known from its two principal origins in mammals, thymus, and the bone marrow. Behind this adaptive immunity lays a complex world of cells, molecules involved in less antigenic specific tasks, collectively dedicated to the function of innate immunity. So it talks about the two immunities there, but how does that affect iron? So as a critical element of cellular activity, iron plays a pivotal role in the fight for survival between mammalian hosts and their pathogens, each displaying a wide range of mechanisms for controlling iron acquisition and utilization. Microorganisms have developed a large number of strategies to acquire iron from the environment and transport the element to sites of incorporation into biologically important molecules. And on the other side, the host has developed the capacity to modulate cellular iron metabolism not only for optimal utilization, but as a catalyst for generation of reactive oxygen species, acting as strong antimicrobial molecules, but also in order to make iron less available for microorganisms. The number of genes and proteins primarily involved in iron homeostasis, namely iron building, transport the storage and are now recognized to display immunological factions. So these are summarized in this table right here, where we can see how iron works in homeostasis for iron chelator, iron transporter, cellular iron uptake, iron storage, iron transfer in late phallogosum, and iron uptake and transfer as well, cellular iron exporter, and the different effects it has. So as we can see, basically summing this up, the mechanisms underlying the different stimulatory effects of infection, iron overload on the hepatocyte are still not understood. Interestingly, it has been shown that levels in fish also both respond to iron overload and infection, demonstrating the evolutionary conservation of its function. So you can see what happens to the immune system when there is iron overload or iron is present in homeostasis. So while iron is helpful and is the most common mineral on Earth, it can have some issues on immunity, as we can see here, reacting to different types of bacteria and different types of entities, as we can see. We can see the iron overload, the macrophage. We can see what's happening with the immunity. We can see the liver-deprived hepcidin, the iron retention in macrophages, the intestinal absorption, the plasma iron. We can see what's happening with the lymphocytes, and we can see the iron-deficient macrophage right here. So in a nutshell, with all of this scientific work, it is important to make sure that you're not getting too much iron and you're not experiencing iron overload. And you can do that by regulating your diet, but it's also a very good idea to make sure you periodically test your water for high levels of iron.